Next, NASA says its Voyager 1 probe, the most distant human-made object in the universe, is sending usable information to Earth again.
When the space probe began experiencing some issues and sent a bunch of code that scientists just couldn't figure out.
Voyager 1 has been making headlines for over 45 years, revealing shocking and unexpected secrets in interstellar space. Not only did NASA use the spacecraft to discover the massive storm on Jupiter and rings around Saturn just a few years after its official launch, but NASA has also warned the world of Voyager 1's recent strange, impossible discovery that has scientists confused and worried. Scientists are conflicted because the information from the system that controls Voyager 1's operations in space does not align in any way with the spacecraft's recent operations. What could this impossible discovery be, and what is the way forward from it? Join us as we take a trip to outer space and find out what has been happening to our universe. Voyager 1's unexpected signals. The Voyager 1 probe has been traveling through space for 47 years since its launch. It is still exploring the regions beyond our solar system known as interstellar space, but it has recently developed a problem that has confused the team of scientists and engineers who monitor it from Earth. Even with its age and the distance of 15 billion miles from our planet, Voyager 1 continues to function well. It can receive commands sent from NASA, carry out those commands, and collect and transmit scientific data back to Earth. But there's a particular issue with one of its key systems, and the gravity of this issue is enough to have you worried too. This system, called the Attitude Articulation and Control System or AACS, controls the spacecraft's orientation in space. It ensures that the probe's high-gain antenna remains pointed toward Earth to send data back to NASA. However, the data readouts from this system do not match what Voyager is actually doing. This means that while Voyager 1 seems to be operating correctly, the information sent back by the AACS seems random or impossible. One of the problems in dealing with this issue is the wide distance between Voyager 1 and Earth. Because Voyager is in interstellar space, it takes light or a signal 20 hours and 33 minutes to travel one way. This means sending a message to Voyager and receiving a response takes over 41 hours. Despite this delay, the team has determined that the AACS is likely still working. The system's irregular data readouts have not yet triggered a safe mode. In this protective state, only essential operations are carried out, allowing engineers to diagnose and fix problems that might threaten the spacecraft. It gets more interesting. The signal from Voyager 1 is as strong as ever, meaning that the antenna is still aimed adequately at Earth. The team of scientists and engineers is now working to figure out whether the AACS itself is generating erroneous data or if another system is causing this problem. They need to understand why the information from this instrument does not align with the spacecraft's actual operations. The Voyager mission, a long journey. The team studying the Voyager 1 probe is currently trying to understand the nature of a confusing issue with the spacecraft. Until they figure out what is causing the problem, they cannot predict if it will impact Voyager's ability to collect and transmit scientific data. This uncertainty comes from a NASA release in 2022. According to Suzanne Dodd, the project manager for both Voyager 1 and 2 at NASA's Jet Propulsion Laboratory in Pasadena, California, this kind of mystery is expected at this stage of the Voyager mission. Dodd explained in a statement from the same year that the spacecraft is almost 45 years old, much longer than the mission planners initially thought they would last. She pointed out that Voyager 1 is now in interstellar space, an area filled with high radiation where no other spacecraft has ever traveled. This presents significant challenges for the engineering team working on the mission. Despite these difficulties, Dodd believes that if there is a solution to the problem with the attitude articulation and control system, her team will find it. If the team cannot determine what is causing the issue, they might have to adapt to it. Dodd mentioned that they might be able to fix the problem by changing the software or using a backup hardware system. if they can identify the source of the issue. Voyager has managed to stay operational by using backup systems over the years. In 2017, it used thrusters that were first employed during its encounters with planets in the 1970s. These thrusters had been inactive for 37 years, but they still worked when needed. The probes are old and generate very little power each year. Because of this, many subsystems and heaters have been shut down over time to conserve power for the most important systems and scientific instruments. Voyager 1 at Jupiter. While Voyager 1 is experiencing this issue, we can't praise it for one of its most historical stops, Jupiter. When Voyager 1 arrived at Jupiter in 1979, many important discoveries changed our understanding of this giant planet. First off, Voyager 1 found out that Jupiter has a ring system. Before this, scientists thought only Saturn had rings. Jupiter's rings are faint and made mostly of tiny dust particles. They are hard to see from Earth, but Voyager 1's close-up pictures reveal them clearly. Voyager 1 also studied the Great Red Spot, a massive storm on Jupiter. This storm is larger than Earth and has been raging for at least 400 years. Voyager 1's photos detailed the red spot, helping scientists learn more about its structure and behavior. The storm has strong winds moving in opposite directions around its center and is a very complicated weather system. Apart from the rings and the Great Red Spot, Voyager 1 also discovered many other interesting things about Jupiter. The spacecraft took pictures of Jupiter's clouds and showed that the planet has many other smaller storms, lightning, and even auroras like those on Earth. These pictures help scientists understand how Jupiter's atmosphere works and how it is similar to and different from Earth's weather systems. Voyager 1 at Saturn. After it explored Jupiter, Voyager 1 continued its journey through the solar system and arrived at Saturn in 1980. This part of the mission was equally fascinating as Voyager 1 made several eye-opening discoveries about Saturn and its moons, as well as its massive ring system. One of the most interesting findings by Voyager 1 was the discovery of new moons around Saturn. The spacecraft identified several previously unknown moons, adding to the list of Saturn's natural satellites. These moons varied in size and composition, and their discovery expanded our knowledge of Saturn's moon system. Another impressive discovery was Voyager 1's detailed study of Saturn's rings. Before Voyager 1's flyby, scientists knew Saturn had rings, but the spacecraft provided unprecedented close-up views and data about their structure and composition. Voyager 1 revealed that Saturn's rings comprise countless individual particles ranging in size from tiny grains to large boulders. These particles orbit Saturn in a vast and intricate system of rings. Voyager 1's observations showed that Saturn's rings are not solid, but composed of numerous individual ringlets, gaps, and divisions. These features are created by the gravitational interactions between Saturn's moons and the ring particles, forming complicated and constantly changing patterns within the ring system. Voyager 1 also took stunning images of Saturn's moons, including the largest moon Titan. These images provided valuable information into the geological features and surface characteristics of Saturn's moons, helping us know their origins and evolution. The search for life, Europa and Enceladus. Voyager 1 didn't stop observing Jupiter and Saturn's physical features. It also took a closer look at one of each's largest moons, Europa and Enceladus, and you won't believe what it found. These moons have caught the interest of scientists because there might be hidden oceans beneath their icy shells. Europa, one of Jupiter's biggest moons, has been on scientists' radar for a while as a place that might have a secret ocean below its frozen surface. Pictures taken by the Galileo spacecraft, which circled Jupiter from 1995 to 2003, showed some features on Europa that strongly hint at a massive ocean lurking under the ice. These features, like cracks and ridges, suggest that Jupiter's gravity and the influence of other moons might be causing some serious tectonic activity under the icy crust. The idea of an ocean beneath Europa's surface has scientists excited because where there's liquid water, there could be life. Water is super important for life as we know it. And if an ocean hides under Europa's icy shell, there could be all sorts of tiny critters swimming around. Scientists think that Europa's ocean might even have hydrothermal vents like the ones we have at the bottom of Earth's oceans, which could provide the right conditions for tiny life forms to survive. Just like Europa, Enceladus has a secret ocean tucked away beneath its icy surface. The Cassini spacecraft, during its mission to Saturn, spotted jets of water vapor shooting out from Enceladus, suggesting that there's water hiding beneath the surface and occasionally bursting out into space. Finding those water jets on Enceladus was a big deal because they not only contain water vapor, but also some organic molecules, which are like the building blocks of life. Cassini also found evidence of hydrothermal activity on the sea floor of Enceladus, which adds to the idea that there might be a lot going on under the ice. The discovery of subsurface oceans on Europa and Enceladus has got scientists thinking about the possibility of life beyond Earth. These moons are like treasure chests of potential life in our solar system.